Alright, so it wouldn't be geometry without some proof, so let's go ahead and take a minute to prove these. Alright, so here we go. I'm going to start with my given that L and M are parallel and that P is my transversal. And I will say that is just given. Okay? The next thing I'm going to say is I always, when I'm talking about parallel lines, I always go back to the idea of corresponding angles. That's the only one that I can just accept. So what I would say is that angle 1 is congruent to angle 3, and that is because they are corresponding angles. Remember, I'm trying to make a connection between 1 and 2. Right now I've made a connection between 1 and 3. How do I get to the 2? Well, what's the connection between 3 and 2? They are congruent. Why? Because they are vertical angles. Now I'm not going to write vertical because they are vertical angles. I'll write vertical angles theorem. And the last part of this, if angle 2 is congruent to angle 3, and angle 3 is congruent to angle 2, angle 1 must be congruent to angle 2. I've kind of cut out this middleman. When I cut out the middleman, we call that the transitive property of equality? Of course not. We don't have an equal sign. It's of so now we've proved the alternate interior angles theorem. Okay, it is the alternate interior angles theorem, but do you see alternate interior angles anywhere in my proof? No. You can't say it's proof by the proof. Okay? And the next one. This is same side interior. So I am missing that P is a transversal as my given. P. So I will say that line 1 is parallel to line 2 and P is the transversal. And that is just given. Now, I'm going to think about this out loud first. I need to say that 1 and 2 are supplementary. Well, I have angle 3 here somewhere. So my connection has to go through angle 3. Well, 2 and 3 seem to be corresponding, and 1 and 3 seem to be a linear pair. Maybe the connection here is angle 3. So let's get started. I will say that angle 2 is congruent to angle 3. Why am I going to say that? I'm saying that because they're corresponding angles. And that is a postulate. Now, one quick thing. When we talk about the things being supplementary, they have to add up to 180 degrees. And if we're going to be adding things, it's equal to 180 degrees. Right now I'm dealing with the congruent sign. So in parentheses, I'm going to say the measure of angle 2 is equal to the measure of angle 3. Now, I will say, what's my connection between 1 and 3? Well, the measure of angle 3 plus the measure of angle 1 equals 180 degrees. And why? Because together they form a straight line. So we call that linear pair property. All right, so now I have a connection. Seems like angle 3 shows up in both of these, correct? So I can't use transitive because this would have to be, if I used transitive, it ends with angle 3. The next one starts with angle 3, would have to be congruent to something. But it doesn't feel like that. So the only thing I can use is really substitution. So I would say, and I'm actually going to use it again here. I'm talking about this one because it has the equal sign. So I'd say the measure of angle 2 plus the measure of angle 1 equals 180 degrees. And that would be substitution, not transitive. And the next line. Whatever you're trying to prove always has to be the last line. So I would say angle 1 and angle 2 are supplementary. And all I've done is change them from being added together, the 180 degrees to supplementary. You would just say definition of supplementary. All right. See you tomorrow.